Welcome everybody. This is going to be a walkthrough for CactusCon 10 bacon recipe. It was a forensic challenge. Fortunately, it's already closed, so I can't do much on the scoreboard right now. But basically, what you're given is a PCAP of some network traffic. And it starts out with stating that there is a suspicious email that was received with attachments. And so they basically ask you to look at the PCAP and try to find the first flag. So the first flag, you can look at a couple of things. I tried SMTP, I tried IMAP, POP, none of those were working. So then I just kind of did email, and there is a GET request to /email. And so if we follow that for the HTTPS or HTTP stream, we will get a blob of JSON data back. So I'm not sure exactly what email client or software this is. But anyways, what we can do is we can kind of start with all this. So here's the JSON data that we received. It's kind of hard to read through. But anyways, if we kind of look through, we can CyberChef is what I'm using. Is this trying to bake? Oh. So I'm just going to do the beautify JSON because it will make it a lot more readable. And I'm just going to kind of look through. Probably also could just do like a search for the flag. But yeah, it's just right here. So you can see flag, get from the organizers. So you put that in there and you get the first one done. The second one that they're asking is a quick count on the number of emails in the Bacon Threat Sims domain. So next thing we'll do is actually let's extract email addresses. So it's going to give us a list of those. And then we only care about the Bacon ones. So we're going to use a reg expression. And then sure you're saying list matches so that it only matches what you want. So we're going to use S plus, capital S plus, so it's going to match any non-white space characters. And then we're just going to do @bacon threatsims.com. And then obviously we have a bunch of duplicates, so we'll do a unique. And we get, if you are lazy like me sometimes, you just do add line numbers, and we get a count of 7. So the flag would be flag bracket 7. Second one, or sorry, third one, is who sent the email with attachments. And so this one was actually, I mean, you can kind of look through it. But the way I did it was, you don't need that actually. We can use a JPath query, which I had not actually used before. So this was something I learned. But anyways, we can kind of, so the format, this is like the root. So it'll show everything, and then this is going to filter it down. And so we could say, if you wanted all the from addresses, you're going to get that. And then you can see that it's kind of nested. So you'll see that like the first thing is a list of some more JSON data. And so we could then do this, and it just returns the JSON data. And then you do another dot, and then you can do address, and it returns the email address. But obviously the important thing is where, which email had the attachment. And so you can also kind of do this. And so you're going to see that there's one right there with attachments. Problem is, you can't see who sent it if you're trying to query it this way. So what you can do is you can actually say, okay, I want to look at attachments, and if it's not null, there you go. So now we have that big blob of data from just that one email message. So now we can do from 0 and then address. Oh, I don't misspell it. So we get payment at shipify.org. And so the flag would be flag bracket payments at shipify.org. So the next one is, can you analyze the attachment in question and find the next flag? So we need to go find what that attachment was. So we have that right there. If we go back and just strip off this from, and then let's do, oh, I meant to do attachment. There we go. So if you look at attachments, you can see there's a couple of actually very helpful things in here. So we get the file name. So we're looking for shipment 303 XLSM. So we know it's a macro enabled spreadsheet. The other thing that's very nice is you also get this checksum, which looks like an MD5, and I can verify that it is. I'm going to, as you can see right there, it is malicious. We'll come in here and we'll see that, all right, this is definitely an XLS spreadsheet. And if we look at the relations, this IP is in our, blinking, it's in the Wireshark capture. And then we can also look in here and we can see, oh, hey, there's a little bit of PowerShell command that it's going to try to run. And we'll see that this get good is also in there. But that's jumping a little bit further ahead. So what we're going to do is we're going to go back into the Wireshark. We'll close that. And then we'll just go into the export objects. We got HTTP, and we can see that right here is that shipment 303.xlsm. I've already downloaded it. And I've actually already copied it over to a Windows. Oh, gotta sign in. This is a malicious file, so I would recommend having a throwaway box. I'm using the virtual machine from Windows, the developer's box. You can basically just throw this into your VM and start it up. And I installed Windows on or Office on this just so I can run this. You also do need to bypass Windows Defender because this will get caught. I had to remove it from quarantine, but it's now back on my desktop. So if we look at this, we're going to see the flag right there. So you can submit that there, and you got that one. The next thing is we already kind of saw this because we looked at the virus total page. It's going to be asking what the URL is for the initial payload, and it's just going to be this little bit right here. So if we submit flag that, it will give you that. But we actually want to start digging into that payload. So if we go back into Wireshark, you'll see that right here we get that get good thing, which I've already saved as well. You'll see that it is a slightly larger file than the original spreadsheet that we got. So if we go look at that, where is it? So here's what get good looks like. As you can see, there's a ton of base 64 in here. There's this new object right here. So it's actually a memory stream, and it's converting base 64. So it's grabbing that. And then you have this variable S, which is going to, so it decodes the base 64 and then stores it as that /s, and you'll find out that it is actually a gzip file. So it will take that, it'll gzip it, and then it's actually executing that code. So I went ahead and so you can basically run, you can extract that out, the base64, echo it to base64D, and then save that to a file. And then that file you would move it to a .gz and then just gunzip. And then what you'll find is you get this payload file. And this payload file is more PowerShell. You can see that it's getting a proc address and delegate type. So it looks like it's going to be loading something into memory, and we get more base64. So I went ahead and I copied this out as well. But there's something important down here at the bottom. If it wants to not jump around, there we go. You'll see that it is XORed with a value of 35 decimal. So what I went ahead and did, I just grabbed all this and then I went straight over to CyberChef again. As you can see, I pasted in that base64. I then used from base64 and then I XORed it with the decimal value as 35. Make sure you don't put null preserving because it will break some of the other investigation that you're going to do. And then you can just save the output to a file. It's going to save it as a .dat, but it's actually a PE file. So next thing, we need to decrypt the C2 metadata and extract the raw key. So one thing, the last one is saying, hey, it's Cobalt Strike. You could have found that out looking at the virus total. So you'd see this get good. We could also take the hash of that get good that we downloaded. So if we just do an MD5 some get good, we can grab this here. And then we can just take this into virus total and search for it. And you'll see that PowerShell downloader, where is it? Cobalt Strike. So you're going to see a Cobalt Strike beacon. So you can assume that it's Cobalt Strike beacon from here. The other thing you can do, which is the next thing that we have to do. So I've downloaded that, downloaded the file from here and saved it as a this beacon.dat. And so I was not sure how to handle this, and what I found out was I just searched for Cobalt Strike decrypt metadata, and this is what came up. So it wants you to actually take that beacon and run this tool 1768 from Didier. I probably just butchered his name, Mr. Stevens. And what it'll do is it will pull out some of the config information from that beacon. And what we're hoping is it has this has known private key, because if it is, then we can probably just decrypt it. So I already have that downloaded. Where is it? All right, there we go. So I'm just going to run it, and as you can see, it's going to spit out a bunch of information. And right here, we can see has known private key. That's exactly what we want. It also gives us this all.js, which if you're looking at the Wireshark, you're going to see that there's a lot of communication that starts to that all.js on the same IP as that get good. So it's probably some type of a callback. But anyways, so we have this. And so now the next part that this talks about is we can now take this decrypt metadata. And what we would do is we would just say, hey, we don't need to go through a whole bunch of the steps because it's not very secure. So we can basically just run the decrypt metadata against one of the, well, I'm getting a little bit ahead of myself. The other thing we need is this CS parse HTTP traffic. And that's going to allow us to find all the encrypted traffic because we don't know what it is. And so if we kind of look here, process memory decrypt traffic, this isn't exactly 100% in line with what we're doing because we don't have the memory dump of it. We have the PE file, and then we have a traffic capture. So we're going to do this part right here where it's the CS parse HTTP traffic. And then we're going to say, hey, we have an unknown key. Just go ahead and give me all the encrypted data. So if we do that, the unknown, and then we're just looking for that bacon recipe. Oh, I need to do more because it spits out a ton of data. You could also just spit this into a file. But yeah, we're going to, oh, actually, I'm getting ahead of myself. This is not actually where we get the metadata. The metadata is actually going to be back in Wireshark. So if you look at these callbacks, um, JS. All right, so here we go, and you'll see this cookie, and so this is where your metadata is. And so if we just copy value, so we should be able to break my, oh, no, there we go. Decrypt. So decrypt metadata, pass this in, and we get our raw key. So we can now take this. This is actually the answer for number 6. So just be flag key, plug that in. But now going forward is, can you decrypt the traffic and find out the first command ran by the attacker on the victim machine? And so I have the actual commands right here because you need to have a BPF filter kind of configured for it. Otherwise, it's going to throw a bunch of errors and it'll make it ugly. But yeah, we can just kind of take this, throw it in. So you'll see that we're doing the CS parse HTTP traffic and we're using the raw key right here. And then those uppercase Y is just your Wireshark filter or the BPF filter. And I'm looking for HTTP traffic that is associated with the IP address of that attacker. So we'll just paste that in. And you'll see that instead of having encrypted traffic, we're actually going to get a lot of data back. And so the first question is, what is the command ran by the attacker on the victim machine? And we see that they run system info. So we would then just submit that. That's that flag. The other thing is we need to extract screenshots taken by the attacker. So we need to figure out, okay, well, which one were they trying to do a screenshot on? And so if we look at the traffic, we're going to see, okay, they were listing files. Looks like there's a flag.text.text. Flag.text. So they actually asked to download flag.text.text, which we'll probably want at some point. But right here is the one we're looking for, is output screenshot. So we're going to look at packet number 2216. And so if we go back into Wireshark, what we can do, because what we're going to want to do is filter it down to the TCP stream so we can extract that file. So if we look for 2216, sorry, it's a little slow. There we go. And then we can just follow TCP stream and it's going to give us, okay, it's 79. So that's how we get that filter for the 79. We do that, we can grab it, come back here. It's that in. So now if we look in our directory, you'll see that we now have this payload, whatever. And if we file type it, you can see that it's a JPEG. So we can just move this quick. And then let's just go ahead and open up GIMP. you can see we have a, and there's the flag. They just put that in for the flag. And then the last one that they had was what's the flag.text content. So it's going to be exactly what we just did. It's just going to be a different TCP stream. So you'd go ahead back into Wireshark. So we'd look up here when they requested that flag.text. You see it's 1928. Go back in there, get the thing. And if we do this, not copy. All right. Like that. Here's our file. Move bacon flag. And there you go. So that's how you solve the bacon recipe. It was a lot of fun. I learned a ton of stuff. I hope you guys found this interesting, and I'll catch you in the next one.